Hello everyone, welcome back to the channel. Today we will tackle a coding question commonly asked during interviews at fine companies. Here is the question. Write a library which supports substitution of string by string variables. Example, if you encounter X in your input string, then replace it with 1, 2, 3, and so on. Here is the input string and the expected output. For the input string, %x %_ percent y should be replaced with 123 underscore 456. So when you are given such question, then first step should be ask clarifying questions. Given the coding round is for 45 minutes and also you have limited time, then you can directly jump to step 2, which is called call out assumption, which will eventually give you some clarification about the question. For example, for this problem, you can see I'm assuming that the variable which we need to replace is always enclosed in %sign in the input string. Okay, let me start with the first step, that is asking clarifying questions. So for this problem, one of the clarifying question can be about the delimiters. I'm assuming that the variable is always enclosed in %sign in the input string, or are there any other formats which we should support here? The second question could be about the nested substitutions. For example, are nested substitutions supported or needed? And you can take an example and mention what do you mean by nested substitution. For example, if a variable value itself contains other variables, should those be resolved as well? Say for X, the substitution string is 123 %y %. So for X, the substitution is 123 %y and substituted string itself requires one more substitution where we need to substitute value for y. So this is called as nested substitution. Explaining your question through example will make things easy for interviewer to answer and might save your time. So use that. The third question could be, I'm assuming variable names are case sensitive. And fourth and final question I have here is, how should the library react when it encounters undefined variables? For example, here %x underscore %y and there is one more here, like for example star and then %z %. So we don't see value for z in our library. So in that case, what we should do? Should we leave the placeholder as it is, or we should replace it with some empty string or throw an error? So these were my clarifying questions here about delimiters, nested substitution, case sensitive, and for undefined variables. So after this, I will provide answers to these questions we discussed on behalf of the interviewer. All the relevant details are available in the GitHub repository linked in the description. After discussing these questions, we should receive some feedback and further clarification from the interviewer. Let's quickly go over them one by one. So the first question was regarding delimiters. So yes, variable is always enclosed in %sign. Regarding the nested substitution question, yes, there could be nested substitution case. For example, you can see it here. So this example is a nested substitution where the variable user within home variable requires substitution. Regarding the case sensitivity part, yes, variable is case sensitive. And the last question was regarding undefined variable. So whenever you see any undefined variable, you should just leave the placeholder as it is and append the string. For example, here in the input string you can see this is the undefined variable, as you cannot see any substitution for z in the library, so you can just take it as it is and append it to the output string, as you can see here. Thanks. After this discussion, you should be clear what the input should be and how the output would look like. Just say that loud to get confirmation or feedback from interviewer, and also to get some confidence how to proceed further. For example, for this problem, I would say input is a string here and output would be a string as well. Now move on to the next step, which is outline the approach. So before we start coding, it's essential to outline our approach using a specific example, anything which is already given by the interviewer, or you can take your own example. And here are the key aspects that should be covered while explaining your strategy. Let me start by explaining approach for this problem. So to handle the substitutions effectively, I will create a hash map to store the mappings between keys and their corresponding substitution strings. The use of hash map is crucial as it allows constant time complexity O of 1 for key lookup. Next one would be what's the algorithm about, and you can give a walkthrough using some example. I have linked all this in the GitHub repository in the description. Now let's move on to talking about what's the algorithm you are going to implement here. So to systematically process the placeholders embedded within the input string here, I plan to use regular expression pattern. So the pattern would be something like this: percent, then round bracket. So this percent marks the beginning and end of a placeholder, and inside the round bracket I will have negation percent, which indicates any character except percentage sign, and the plus sign indicates not just one, there could be one or more such characters, and this forms my regular expression. To apply this pattern, I will utilize Java's pattern and matcher classes, iterating over the input string to find each match. Now explain the interviewer like how your loop will behave, what are the parameters the API will take, everything. Don't wait for the interviewer to ask you, so just give them API walkthrough. For example, the function will accept a single string input that contains the placeholders to be substituted and the hash map. Example, say this is the API public, it will return a string, resolve string, and the input will be some string, say str. When you are just explaining on the word, make sure just to use a tab. Okay, this will be easy to format your code and you don't have to just struggle with that. So once you start explaining this API, just use one tab and it can be used to write all other variables and loops in it. So let me talk about how the loop works. First, I will initialize my result variable, which I will return at the end of the API. I'll compile the regex pattern. So using Java's pattern class, and here I will have my regex. Also then I will use a matcher here, matcher, to scan the input string. So just leave this comments while explaining, then you can come back and write the whole code. This is just like outlining the approach, so you don't have to delve much into details, but this will help you at the end to improvise your code, or just if you stick to this approach, it will help you to write the code. I will use matcher.find method to find next sequence that matches our pattern. So basically this method will return true if it finds pattern in the input string, else it will return false. So the loop will continue as long as the matcher.find finds new matches. Something like this. So inside the loop I will use matcher.start and matcher.end method to help me manage the text around the placeholders. For example, suppose this is my input string. What the matcher.start will do is it will return the position where the match substring begins. So here, like the first substring which matches is %x%, and its index will be 0, and matcher.end, it will return the position that marks the end of it. So it's 0, 1, 2, but it returns the next position after the closing percentage sign. So it will be 3, not 2. But suppose if I have something at the very start, example hello, if whenever you are explaining any example, take some relevant text. Just don't take ABCD, so that it's easy for the interviewer to understand, and it will help you also. Suppose I have something like hello at the very start of this input string, which doesn't need any substitution, and this can be appended to the result string directly. So what I will do is I will maintain a variable, say last end, to track the end of the last processed match throughout the loop. So initially it will be 0, and it will be updated at each iteration. For example, now here the starting will be 5 and end would be 8. So when the match is found, the first thing would be to append the part of the string from the end of the last match, denoted by the variable last end, to the start of the current match. So here the last end is 0 because this %x% is our first match, and the start of this current match is 5. So we will append from last match, which denotes the last end of last match. Here it's 0 to the start of the current match, which is 5. So it will be something like this. I will take substring and provide last end and start. This piece handles the text that doesn't contain placeholder and adds to the result. Now here there will be some logic to process the placeholder which we have found. I will come back to it later. So now we need to update the last end here using matcher.end, which is 8 here. So it's the index right after the closing %. The reason behind this updating the last end is we can use this to append the text that doesn't contain placeholder, like we have seen this hello text here. So after this also, after the first match, there would be some text which would be similar to hello and won't need any substitution. When we find start of the next match in the next iteration, for example here in the next iteration we will get %y% and the start will return index as 8 here because that is the index of the opening percent sign for this y. Before processing %y%, you need to append the substring from last end, that is 8 here, to where which is 9 here. So we will append the string from 8 to 9, which is an underscore, to the result, and then we will process the placeholder which we have found, and again we'll update the last end with 12, which is closing percentage sign for our next match. So once all the placeholder matches have been processed and the loop ends here, we need to append any remaining part of the original string that follows the last match. Say our last match here was at index 12, that is %y%, and there was some additional text after that, say coding. So we basically have to add this coding after the loop ends to the final result. So this piece basically handles appending remaining part of the string, if any, after we are done with finding all the matches. For example, here it will append all the remaining text after index 12 and return the output. So it will be result to string. And so now coming back to the logic to handle placeholder here. Say we have found our first match %x% using this matcher.find method. So each time when we find a match, we would use a method called matcher.group1. So what it would do is it would give us a match for this regex pattern. So group indicates something which is enclosed in round parenthesis. So when we say group 1, so it indicates first group that is enclosed in round parenthesis in the regex pattern. Here we just have one group, but like if there are more than one, for example, this was one of the group, right? But suppose there was one more like round bracket in this regex pattern, then it would give us that second group. For example, here it was %x%. So if we matcher.find will basically give us directly this %, will get output as %x%. And what this matcher.group basically would do, it would give us x. It would return the content captured by first capturing group in the pattern. Groups are separated by parentheses. Here group 1, we have just one, and it would return the like placeholder without the percentage sign. So here it will just return X. So in this percentage sign, if there was one more group, some pattern here, I would say percentage with I would say some XXX pattern. So this would be our group 2 inside the percent sign. So if this was so it would give that group to us. So suppose that pattern matches this string, it would the group 2 would return. If we pass 2 argument here, it would basically give us dy dy by. Okay, so that's about the group thing. Let me remove this. Okay, and I will then look up this key in our hash map. So it will be, suppose my map dot get key. Now there could be two scenarios here. If the key doesn't exist in the map, I will just take that placeholder and append it to the result. So this will be the piece which would do that. So here we have just appended matcher.group. So what the matcher.group will return is, it will return the text along with the percentage sign. Okay, if we pass 1, then it would basically return the first group, the text in the first group which matches the pattern, which we have used here to check if the key exists in the map. Now next would be, if the key exists in the map, then I might encounter nested substitution. So I would use a recursive call to our API here to handle that before appending it to our result. So it would be something like this result dot append, and I would call the API again for the replacement to check if there are any more substitutions which we need here, and that would be basically my recursive call. And after that I have to update my last end as I discussed. So here, after we are done with processing this placeholder, I would update my last end from 0 to 8. Again, it would give me percent by percent as my next match. Then basically I would append if there is any string between these two matches which doesn't have any placeholder. Then I would start processing my match by taking the text between this percentage sign. Here I will get Y, and I would again check if that exists in the map. If yes, then I would basically check if that replacement have any other placeholders. So this is the call which would make sure of that and process it. Now regarding the space and time complexity, space complexity wise, it should be O of k, where k is the total number of entries in the map. For the time complexity, overall time complexity of this approach is primarily dependent on the number of placeholders and the depth of the nested substitution. So generally it would be O of n into m, where n is the length of the input string and m is the number of placeholders to process. To be very specific, Say if the length of the input string is s, then scanning the input string s with regex to find all the placeholders would take O of n here. So this would be O of n. And for each placeholder, the time to resolve it is not just replacing the string, but it may involve further recursive calls, like how we have seen here. So if the replacement string itself contains placeholders, if each placeholder is replaced by a string of average length, say m, and we assume that the replacement can also contain up to k placeholders on average, so the recurrence relation here would be something. Suppose this function takes t of n time, and this whole while loop iterates once for each match found, and on average the replacement string is of m length, so this would take tm time, correct? So now here, if each placeholder is replaced by a string of average length m, and if we assume that the replacement can also contain up to k placeholders on average, so the recurrence relation would be something like this: t of n equal to O of m plus k into t of n, because here each replacement can contain up to k placeholders, right? So sorry, it will be t of n. Suppose these replacements are shallow, that is not nested deeply, this may simplify to a function mainly dominated by linear scanning of n and linear resolution of substitution, making it roughly O of n plus m into k. But if we need to consider the depth as well, so if k and m are constants and d is the depth here and d is the depth here, so the complexity would be approximately O of n plus k to the power d into m to the power d. So basically, like on the first level, it will resolve the main string of length n, so it will be O of n. On second level, each placeholder might lead to resolving a string of length m repeated k times. So k into t of n. And so if replacements at next level have two placeholders, so they will be resolved to, so basically it would lead to k square into tm square. And how did I derive that? It's from the second level. So as you can see, at second level, when each replacement would have average of m length and it would take t of m time, and there might be k such placeholders. So in this k placeholders, there would be again such k placeholders where average length of the replacement would be m and it would take t of m time. So this is how we will get this from k placeholders. Okay, and this was our original k into m, which would give us k square into tm square. If you want to learn how to derive this recurrence relation from a given pseudocode or further levels. Now let me complete the code. You can just say that to the interviewer. Wait for him to say, okay, you can go ahead, or I got what is needed, and okay. So here the string builder. New. Okay, you can remove this. Then the pattern class, like I have mentioned, and for the matcher part, I would pass the input string to the matcher method. And in the while loop, this was the example. Yeah, so this is how it should work. If you want to learn how to derive this recurrence relation and derive time complexity, I will add links to those resources in the description. Now you can talk about the efficiency of this algorithm and potential improvements and limitation of it as well. So starting with the efficiency, this algorithm uses hash map for quick lookups, and the efficiency of the regular expression engine in Java are key optimization which I have used here. Also, the recursive substitution allows for the handling of nested scenarios without multiple scans of the input string. Regarding potential improvements and limitation of this algorithm, so the current setup might face performance issues with deeply nested substitution or very large input strings due to recursive calls. We can implement a caching mechanism for previously resolved placeholder to reduce processing time for repeated patterns. Yeah, and you can end with that. And if the interviewer asks you to implement that improvements, then you can do that.